show and describe dispersion of the data or spread of the data of univariate data using one variable data set. And so if we look at spreadsheets, I'm just going to enter, we're looking at military data for this problem, salaries of different military jobs, higher professional level military jobs. So I'll just label it salary since we do have a context for this problem, and then we'll just go ahead and enter the 10 salaries that I have for the spreadsheet. $110,590 is the last one. So that should be 10 values. So now I'm just going to go to, just highlight one of the boxes of that data set, go to Menu, Statistics, Calculate, Stat Calculations, One Variable Statistics. Yeah, we just have one data list, so salaries. So we're going to go and look for that name and next one list. Salaries, only one option. Frequency of just one time, and we want it to go just in another column, so B is fine for that column that's listed. And when it shows you the one variable data, it looks just like it does on the TI-84, but you can see that it shows you the mean of 134,670. There's a sum of the x's. That doesn't really show you much except for when you get down here. Standard deviation of the sample, you don't look at the sigma one because that's population, and we don't have the population of the entire military. We're going to look at S sub x. So 37,940.4 is what they should have got for standard deviation for the sample. It does show you median and quartile 1 and quartile 3 and minimum and maximum that they can use for finding that interquartile range and looking for those outliers, but I also provide a key in the section of this lesson in the ccbetterlesson.com. So if you had, I just went ahead and squared. There may be a way to see variance on here, but I don't see it right now. So I just went ahead and looked at the sample standard deviation right there, and since taking the square root of the variance gives you the sample standard deviation, I just went ahead and squared it, and that gave you a large number, 1,439,476,987. And that's why when you're working with real world data, variance is supposed to show you the spread away from the mean, but standard deviation makes much more sense. Variance is a very large number usually because you're squaring those values. So usually standard deviation is something we'll refer back to of how each data point's deviating from that mean.